Hello everyone, welcome back to our session. And I think today we are going with the IoT hackings.
Recording in
Okay,
progress.
let's see. Yeah. So we are going into the module 10, IoT and OT attacks and countermeasures. Okay. So this is going to be our objectives for today's class, like understanding the IoT concepts, understanding the IoT attacks and attacking tools, and overview of like how to like mitigate those attacks in our tools, and understanding the OT concept and OT attacks tools and their countermeasures. So let's dive into it. IoT attacks, and this is going to be our flow. Understanding the IoT concept. So what is an IoT? IoT is an Internet of Things, also known as like Internet of Everything. Refers to the network of devices having IP addresses and the capability to sense, collect, and send data using their embedded sensors and communication hardware and processes embedded into them. So in IoT, the term thing is used to refer to a device that is implanted on natural or human-made or machine-made objects that has the functionality of communicating over the network. So here, so here they have some images to like differentiate those IoT devices which we are coming across like in our day-to-day life. So we obviously use like today's like smart watches, like whatever the wearable devices, and we have TVs and etc. Actually, TVs is not like a normal TVs like tube TVs. We are talking about the Android TVs, which can able to connect to the internet. So whichever the device can able to connect to a network or an internet. So those devices we call it as IoT devices. So in the industries we having some of the tools and the manufacturing tools and transportation nothing but they will be embedded a GPS into the devices, and also we have like monitoring tools as itself in the warehouses. So those will be coming under the industrial devices. And for healthcare, so for an example of healthcare, we can able to give the heart sensors. I'm not sure. I forgot the word here for the device. So which the device will monitor the heartbeats, and it will also like try to get the rhythm out of the heart. So if the rhythm is not like a normal rhythm of heart, so it will try to like give a like electric pulse to the heart, and it will like retain the rhythm back. So and also not only that, we have like the sugar monitors, which will be connected to our devices like phones or things, and also etc. And in home devices like the monitoring like the CCTVs or like IP cameras and thermostats and the solar panels which will connect to the network to internet or something. So these are all called the IoT devices. Okay, so normal IoT devices will be having a kind of a sensor. A camera is also a sensor, a temperature monitor that is also a sensor, an infrared sensor, everything which can able to sense the environment in it. That is called an IoT. Even we have the IoTs for plants as well. So those devices can monitor the humidity level, the water level, and also the plant's health as well, and the oxygen level, etc., and the nitrogen level in the soil, etc. So we can also have some devices like that. Okay, and it is a, like a constantly evolving field as well. And how the IoT works. So yeah, it is basically the IoT devices will be connected to a network through Wi-Fi or any mode of communication, and it will be connected to the internet to store the data and also process the data in a remote location or in a remote devices like a mobile phone, or it might be a server also, or it kind of any monitoring devices. Okay, let's go further. An IoT architect. So like architecture is nothing but how it is framed, how the devices are framed. So it obviously it will be having application layer, middleware layer, internet layer, access gateways, and edge technology layers. So name the edge technology where the sensors will come, the sensors, the devices, machine, the intelligent edge nodes of various types. So what are the sensors we have? Those will be coming under here. So from there, it will be accessing the internet. So through internet, so we have a gateway. So we should need a like authorization or authentications where this device is an authorized mode or not. So those things will be handled in the access gateway layer, the protocols for translation and the messaging ones, and the connection to an internet itself, the connection between the endpoints. And middleware layer, the devices management and the information management will be taken care in this layer. And finally, the application layer, which will deliver the various application to a different users in the IoTs. Let's go further. Yeah, application layer, sorry, the IoT application area and devices. So yeah, so we have these, like actually these are like limited ones. So we have like much more than this comparing to like in this table. So we have like various other technology or various other more IoT devices as well. So each will be unique in their own models. So here, let's take an example. So we have vehicles that like is using in the consumer side, commercial or construction side. It can be implemented in anywhere. And those devices might be like the vehicle GPS itself and the lights, so which can able to like sense the environment, whether we need to turn on the lights or not. And we have ships to track their locations and things, and planes, which also has the sensors and signage tools and etc. The tools actually in India, nobody's using the other kind of tool in sensors which the foreign uses. What actually they are trying to like implement those IoT devices in the tools as well. So whenever you are entering into an highway, the sensors will detect your number plate and your location where you have entered, and then it will be automatically detect when you are getting out of the highway itself. So it will automatically sense your distance and the charges. It will be sent it to your phone as an SMS, and it will automatically, if you are like using a credit card, it will be automatically credited from there, or we can able to use the fast tag, or we can able to implement those itself. So those will be coming under the tools as well. So yeah, we have like various kind of devices, like IoT devices, which can able to implement in any kind of service sectors. It can be healthcare, it can be energy, buildings, etc. Or else in our consumer, like normal use of homes, actually. Okay. Yeah. And yeah, it is continued here. The same kind of IoTs. Yeah, pumps, water pumps, and valves. These are all for lot like industrial purposes. These are agro-industrial, like agriculture industries, services or sectors. And POS is for the retail centers, etc., etc. Let's go further. Discussing of IoT threats and attacks. So why we need to create an like a security for an IoT in the first place? The thing is, it is an endpoint. It is like an easy endpoint to connect into a network. The obvious thing is we have to secure our network, so in order to secure the whole organization, right? So, and a Wi-Fi is an entry point, as an access point, right? So same thing which comes to an IP cameras itself. So if we can able to lay a hands on and like IoT devices, and if we can able to take over it, so we can able to like morph into it. We can able to like predict, like we can able to pretend that we are an IoT device as an attacking device. We can change it to an IoT device, and then we can enter into the network without any detection or things. So that is why the hackers will mostly concentrate on IoT devices. So if you can able to come across this game like the Watch Dogs 2, so on that game actually, he would be mostly using the IP cameras to enter into the network. So it is not an exact hacking, but the concept is similar. Okay, so using a security camera, we can able to enter into the network, and we can able to take down the whole network itself. And yeah, so what are the challenges we can able to face in the IoT? So the lack of security and privacy, and clear text protocol and unnecessary open ports. That is also leads to an attack. Okay, so can we do an audit on the IoT devices? Yeah, which will come in an internal audit. So we have to look into the IoT devices. We have to check for whether the firmware is up to date, or like they are using an like what do you say, the vulnerable IoTs and etc. So we have like separate kind of like internet testing for IoTs even. So we have to take an audit. Actually, these audit will be taking place like will happen on each audit year, like April or June times. Okay, and whenever you are going for an audit, you have to go for a third-party service, like third-party companies for these services. You can't, even if you are having the resources in your organization, you have to like go for the third-party audits. So that is not. It is like a mandatory thing. Okay. So and we have vulnerable web interfaces. So yeah, each and every IoT management will be coming across in the same router login itself. So if the like what do we say, if the interface is vulnerable, it's game over. And can you suggest a few ways to do audit on the end of a session? Actually, it is an internal based thing, so we can't able to. So I can't able to use our like company resources for this purpose. But uh, yeah, we have some courses for it. So if you opt for the course, we can able to show you the next. Okay, I can able to show. I can able to give you an overview on it. Okay. So we have the automation tools and things to check on it. But basically, if it is an internal testing, we have to go to that actual organization, and then we have to check for the documentation and things. So how they are managing their IoTs is also another point, and also what are the modes of connection it is doing, and whether it is like any other services it is opened, whether there is IAM is taking care over there, or whether it is implemented or not. So those are also coming under it. It is not a single thing. We have to look for the multiple things. Okay. And coding errors like buffer overflows here. So it is not the right thing. The coding error is nothing but it is the logical flaws which is implemented in the devices itself and legal and regulatory and rights issues. So if it is not a compliance, if it is not coming under the compliance, it is an issue also. And storage issues like even though if the IoT is secure and the network is secure, everything is secure. If the storage where the data is storing, if it is not secure, means that is also there is like not like there is no point in it, right? If you want to secure the data, the storage area is also should also secure. Default and weak and hard coded credentials. Hard coded credentials are like using the weak or default credentials is the main flaw here. And the difficult to update the firmware and the voices. And that is also a thing. So actually previously, nowadays IoTs are like, we can able to easily like update their firmwares in a single click using like a management device. But in previous things, we have to like disconnect the IoT from the network and we have to like what it is, update the firmware manually for each and every devices. So nowadays it is not, but in the previous time it is difficult to update. Okay, let's go further. IoT security problems. So we have like the applications where the validation of the input streams are then an RZ, no automatic security updates and default passwords will happen in so these are all the problems in application layer. And we have network. So the firewalls and improper communication encryption and services and lack of automatic updates will also leads to an attack. And mobiles like insecure APIs, lack of communication channels, encryptions and authentications, or lack of storage security will also leads to an attack. And in cloud, so improper authentication of a device like an IoT device and no encryption for storages and also communications and insecure web interfaces. So here you can see that the communication is the main thing here. So each and everything, each and every like modes of transport is also a weak link here. So if the transmission from a device to a network and the network to a like a storage unit, so over those area we have to like what do you say? Implement an encryption over it. If there is no encryption, means even in any bypasses, in any transaction, if you can able to sniff, there is no like point in securing the other things. Okay, and in IoTs, the application plus network plus mobile plus cloud is equal to an IoT. Here, the mobile is nothing but the technologies which is implemented in the IoT itself, which mode of it is used. Okay, and these are all the OWASP top 10 IoT threats here. So we obviously actually this is our top 10 attacks which is happening in the IoTs. Okay. But more than that, there's like more than these also we are facing some attacks other than these which is mentioned here. So as usual, the weak or guessable passwords and insecure privacy protections and insecure network services, insecure data transfers and storages, and insecure ecosystem interfaces. Ecosystem interface is nothing but the whole network is not having a secure interface, a secure mode of transportation of the traffic and lack of device management. We have to manage devices. It is not a simply like plugging the device and working on it. So you have to manage a device constantly, whether it is whether the IP is different or not, whether it is like giving a wrong information, whether it is not working properly. We have to manage according to it. And lack of even though if the IoT is damaged, we have to make sure it is like updated, the device is changed, things. Or else we have to like eliminate those connections to it. So if any device is damaged and we are not taking care of it, means anybody can able to access it. So instead of an like what do you say? If I'm looking into that, if I'm looking that any IoT devices is like open but damaged and it is not working, what I would do is I would be simply implementing an access point over there. It will be looking like over there that it is working. So they might be thinking it is working, but the thing is like I've already like tampered the device itself and etc. And use of like insecure or outdated components and frameworks and lack of physical hardening. Okay, let's go further. The lack of physical hardening is nothing but nobody can able to access our IoT devices. So if they can able to physically easily accessible means that is also a no thing. If I can able to access the IoT, I can able to easily switch the device with a tampered thing. Okay. So we have the IoT threats of the DDoS attack as in the first place, and we have the attack of hijack systems and rolling code attacks. Rolling code attacks. Can anyone know why it is coming here? The rolling code attacks. Do you guys know what rolling code attacks are? Rolling code attack. Okay, I'll give you the example here. So most of the people, some people here might be using your cars for transportation. So you might be obviously using a remote to lock your device, or lock your car. So on the time, whenever you're clicking, X sequence of code will be transferred from your remote to your car. So if the car receives that data, it should be locked. If the receives the another data, it should be unlocked. So that is only there is two data has been transferred. One is for unlocking, another one is for unlocking. The thing is, using the replying the code, if we capture the signal, it is like RF only, radio frequency it is. So if we can able to capture the code and then if we transmit it, it is obviously going to unlock the code. So that is why the technology has been updated to a rolling code. Rolling code is nothing but it will be like it has four patterns of codes for unlocking and then locking the cards. So it will be a pattern. Okay, so if we can able to find the rolling codes or like the 4 or 6 rolling codes, we can able to identify the pattern and then we can able to easily unlock the code. So that is what we call rolling code attack. Okay, and we have a bluebone attack. We have jamming attacks. We can able to jam the IoT devices like kind of an EMP, can use EMPs and remote accessing using backdoors, remote access using telnets, cyber attacks, exploiting kits, man-in-the-middle attack, etc., relay attack. So we can able to expect these kind of like STRS, the radio-based attack it is, and fault injections, etc., etc. Let's go further. If you have a question here. So what is bluebone attack? Bluebone attack is nothing but it is the firmware attack on IoT devices. Okay, actually, bluebone comes under Bluetooth attacks. So if the IoT is what do we say? Transportation is going through the going through the Bluetooth means we have the what do we say? Exploit for Bluetooth. So that is what we call bluebone attack. So the attack is based on Bluetooth. And yeah, let's go further. General scenarios, hacking IoT devices for general scenarios. So we will be continuing with the Dribble attacks and SDR attacks. And SQL injection attack, which is like the data is going to be stored in a table format, right? So we can able to inject a SQL code over there while it is passing the data. So it is going to be obviously encrypted. So we will be encrypting our SQL code itself, and then we'll be transmitting the payload into the traffic. That's it. And eavesdropping. First, we will be eavesdropping the whole network, and then we'll be taking the access to it. So eavesdropping is nothing but if it is like using a Wi-Fi or Bluetooth, we can easily guess what are the IoT devices that is being implemented over there. And then if we can able to access the router itself, we can able to easily get into the network itself. Okay. And we can able to implement a fake server. We can able to divert the traffic into our own fake service as well. So here now we are into the DOS attack. So we obviously have some idea on DOS attacks or DDoS attacks. So in here, attacker initiate the attack by exploiting the vulnerabilities in the device first, and then installing a malicious software in their operating system. And once it is done, multiple infected IoT devices are referred to as an army of botnets, and the target is attacked with the large volume of requests from the multiple IoT devices present in the different location. Okay, instead of we are having we will be like having a like other devices such as like any other botnets, we will be making their IoT devices, their own IoT devices into the bot network, and then we'll be starting the attack. Instead of a normal data, we'll be sending a multiples of data to the server, and then we will be crashing the server. So this is the concept here. So here the attacker gains a remote access to a vulnerable device. It can be any one of the devices here. And then the attacker injects a malware into the IoT device to turn them into the bots. So let's consider that every device has the vulnerability, and then he injected malware into each and every devices. So once it is done, it will be these botnets will be communicating or like having a connection to the C2C server and then a CNC server, and then it will be starting the attack. So each and every devices in the bot network will send a loads of data into the target server. Hence, the data will be hence the server will be crashed. Server goes offline and unable to process any other further requests coming from the devices. So please increase your sound. So sorry, this is the possible sound I can able to produce here. Let's go further. Exploit the HVAC. So many organizations use the internet connected heating, ventilation, and air conditioner and HVAC systems without implementing the security mechanisms. This gives attackers a gateway to hack the corporate systems. So HVAC systems have many security vulnerabilities that are exploited by the attacker to steal login credentials, gain access to the HVAC systems, and perform further attack on the organization network. So here they have given the image here. So to understand, so first let's take the attacker is like attacker using the showdown search for the vulnerable ICS systems, and then attacker tries the default credentials to access the ICS systems. So once it is done, the attacker will gain the access to the HVAC system through the ICS, and then attacker will be gaining the access to the whole organization itself. The HVAC actually does nothing but it is the management portal. So if you are using a router in your home, so you can able to access its management thing in the browser itself. So if you like open your browser and type in 192.168.1.1 means you can able to easily open the management portal of your router. So from there you can able to manage the traffic. So you can able to block the things. You can able to implement a VPN over there. You can able to tunnel and tunnel to like a static IPs as well, or to your server too. Can be able to done. So you can able to manage the things, right? So the same thing here for the IoT things, like for these like heating, ventilation, or air conditioning systems, you will be having a management access, a management portal. So from there we can able to easily get into it. Actually, if we are using an IP like security cameras, so if it has a login portal, so somebody might be like using a default credential. So from there we will be going or accessing into the HVAC systems, and then from there we can easily enter into the organization. Okay, so let's take, if you are using a static IP to your router means, I can also easily get into your management login portal. So if you are using an what do we say, like a default credential, and I can easily like manage your router. So from there I can able to get the information out of your any other connected devices into the router, or etc. etc. It can lead to many problems. The same, instead of like a router portal, we'll be having an HVAC system over there. Okay, so a rolling code attack, as we already discussed about here. So your victim presses a car remote button to unlock the car, and the car, okay, here it is third one. Okay, the same thing. It can be unlock signal, or it can be a lock signal. and which will be transmitted through the RF, radio frequencies. And it is straightly going to the car, and it will car receives it, it will be unlocked. The thing is, the attacker will be jamming the signal, not jamming actually, he might be sniffing the traffic or the signals, and once he captured it, he can able to retransmit it, or he can able to store those codes. And once he got every rolling code he has, or he can able to guess it also. If we have like only two unlock signals and two lock signals, he can able to easily predict the pattern, and then he can able to create it. The thing is, most of the rolling code features which the car is using now is like only like some more like 3 or 6 kind of patterns, or 6 kind of variation of codes. That's it. So even if they are using a rolling code also, it is very easy. But if it is like only they are only capturing the one particular signal, it doesn't work. He needs multiples of signals to predict the pattern out of it. Okay. This is how it happens. So the victim is pressing the car, pressing the remote to unlock the car, and the signal is received by the attacker, and he or she can able to retransmit the signals to the car to lock or unlock the device or the car. Yeah. And now we are into the blue mode attack. Let's see. Blue mode attack is performed on Bluetooth connection to gain access to take full control of the target device. After gaining access to a device, the attacker can penetrate any corporate network using that device to steal critical information about the organization and spread malware to the nearby devices. As it is, instead of an Wi-Fi access point, we will be having an IoT device which has a Bluetooth connection. So first, the attacker will be discover the device itself using the discoverable mode, and then he will be retrieving the MAC address of the device, and then he would be retrieving every information possible. And then once it is done, he would be spoofing his own MAC address for the device, and then he would be gaining the access to the network. Or it might here in this image, it is a printer here, and he's take control over the printer, and then he can able to access the whole corporate network in the first place. For this kind of attack, you have to be present nearby to the network or to the device. Okay, let's go further. Jamming attacks. We obviously know what jamming is. He or she can able to easily disrupt the whole network itself using the jamming devices. Okay, actually, it is not a legal thing. If you are if the attacker has jammed the radio signals over the particular location, so no IoT device is going to work, or it will work, but it can't able to transmit the signal to the storage server or any kind of management servers. As a result, the network gets jammed, and which disables the endpoints from sending or receiving any messages. Okay. And now we are into hacking smart grids or industrial devices, remote access using backdoor. So obviously, which we discussed. So instead of accessing the whole network using a particular device, we can able to implement a backdoor to it. So that we can able to easily, or the attacker can able to easily come and go after the backdoor which he created. So the backdoor can be implemented or inserted using any vulnerability present in an IoT. Okay, let's go further. Yeah, SDR-based attack on IoT. The attacker uses the software-defined radios, so the devices which we use, like the hackathon kind of devices, to examine the communication signals into the IT network and send spam content or text to interconnected devices. And yeah, so these attacks can able to possible using the SDR devices, like the replay attacks and cryptanalysis attacks and reconnaissance attacks can also happen using the SDR devices. Okay, and we have fault injection attacks. Fault injection attacks are also known as the perturbation attacks. Occurs when perpetrator injects an faulty or malicious program into the system to compromise the system security. So these type of fault injection attacks, or like optical or electromagnetic fault injections, or EMFI and body basis injections, or BPI. The attacker inject the fault faults into the device by using the projecting lasers and electromagnetic pulses. So simply like EMPs. And the power or clock reset glitches. The attacker inject a fault or glitch into the power supplies and clock network of the chips. And a frequency or voltage tampering. So increasing the voltage will also disturb the devices, right? The attacker tamper with the operating conditions or modify the level of power supply and or alter the clock frequency of the chip. Actually, it is not easy. It will be totally like damaging the device in the first place. And temperature attack. The attacker alter the temperature for the operating the chip and affecting the whole operating environment itself. It is nothing but it will be it is like re-editing the code of an IoT devices. So most of the IoT devices is using similar kind of like a chips. So if the chip is manipulating, if we can able to manipulate the chip, we can able to easily try to do any kind of attacks which we see here. Mostly it will be the EMFI. Okay. Electromagnetic pulse can able to disrupt any kind of devices. Okay, and capturing and analyzing an IoT traffic using a Wireshark. So it is very simple here. Actually, they are using multiples of commands here, and this is like for normal Nmap scan. We don't use like Wireshark for this. We just need an Nmap tool. And if config where we can able to identify like which are all like open hotspot we are having, and running an N or M of ng to put the wireless card into the monitoring mode. Yes, and once it is actually they are giving the steps here. So yeah, first we will be what do you say, enumerating what are the ports are open in the target what is in the target IP address. So what are the ports are open from there? We can able to guess or analyze which port it is used for the VLANs. So once it is done, we will be configuring our own VLAN to in a like a monitor mode, and from there we will be fixing what or which wireless network we are going to target. And once it is done, we will be discovering the target. Oh yeah, it is done. And next step, your wireless card to listen the traffic on the same channel using the RMOP-NG. So from there, if we will be like capturing, from here we will be come back or like goes to the Wireshark, and then we will be recording the traffic which is coming and going out of it. So yeah, here it is. We launch a Wireshark and double click the interface that was kept in monitor mode, and here VLAN 0 mode and start the capturing the traffic. Okay, so this is a typical analyzing the traffic. What are the IoT tools we are having? We can able to use firm analyzer that enables the devices, vendor, and then security professional to perform an automated security assessment. I think we had a question on this. How do we do it? So using these kind of softwares and softwares that powers IoT devices firmware and to identify the configuration and application whatever it is. Actually, this particular tool will give us the things which we have to look for. So it is only looking through the software kind of things, not on a physical level. So once it is done, we will be going for the physical audits. We can able to use any kind of these tools, but basically we will be using two kind of tools, or like not two kind of, like two similar kind of tools, which will give us like obviously because these are like automated things, right? So we can able to expect some false positive vulnerabilities and things, false positive outputs. So from there, we have to compare the two outputs from a different tools, and then we will be like analyzing those outputs. So we will become like we will be shortlisting which is the legitimate vulnerabilities or like no-go vulnerabilities, etc. So from there, we will be giving the report to the clients. Okay. Hacker of one, and actually it is a device. Yeah. So now we are going to discuss about the countermeasures or mitigations of these attacks. What are the countermeasures where we can able to defend ourselves from these IoT attacks? So disable the obviously like the easy guessable password or like the default passwords, credentials, and use the lockout feature to lock out accounts for excessive invalid login attempts. So for these is for those management logins. So if it is possible to have a lockout mechanism or feature, it is like recommended to turn it on, and implementing the strong authentication mechanisms like multi-factor authentication or biometric authentications, and locate and control system, locate control systems or networks and devices behind the firewall and isolate them from the business network. So if in case you have to go with the ID devices, that means you have to make a separate network for it, a separate serving storage servers and things or management servers should be isolated from the organization network itself. Even though if the IoT is compromised, it should be only compromising the IoT resources, not on our organization things. Actually, we call these as an DMS, sorry, DMZs, demilitarized zone. So we will be putting these servers and things with like mail servers and other things, which can able to easily recover, or if it even if it is like under attack or it is compromised, means it doesn't care. These are all things in the DMZ zones. So yeah, and implementing end-to-end encryption and using public key infrastructure or PKI or PKI. And yeah, it is simply encrypting the traffic. That's it. And patch vulnerabilities and update the device firmware regularly or in regular basis. So actually, that is what the security professionals in the first place. They will be constantly monitoring for the vulnerabilities. If there is any vulnerability present, it will be transferred to a particular team. So though like those team will take care of those updating things and etc. So we mostly will come across the IT team. Okay, and we have IoT security tools. Sorry, IoT security tools like CCAT here is a security first SaaS technology to operate the IoT products in a reliable and scalable and secure manner. So instead of like a managing system, we can able to use the CCAT itself, and we have Fortinet and things. Fortinet is nothing but it is a one of a feature or one of a product from Fortinet technologies. Okay, and we have Cisco IoT threat defense as well, etc., etc. Yeah, we can able to use these tools as well. And these tools, especially why we need is like it will automatically alert the admin to whether a particular device is up to date or not, whether there is any like update is available or not. And also from here itself, from this management portal itself, we can able to update those IoT devices. Okay. So now we go with the OT concepts. Yeah. Operational technologies, or OT, is the software and the hardware designed to detect or cause changes in the industrial operation through a direct monitoring and or controlling the industrial physical devices. The OT is consist of industrial control systems or ICS to monitor and control the industrial operations. So it can be unique things like any kind of sensors, which is like managing or transforming the data to like process in the endpoint. Okay, so it is just like a minor difference from it. So IoT is different and OT is different here. Okay, let's go further. Yeah, fire extinguisher is a real thing here. Okay, like starting the fire alarms and etc. And rerouting the waterways to the fire hydrants, etc. Okay, so essential terminologies which we have to look for here. Those are like assets, zone and count or count units here, and industrial networks and business network. So OT system consists of a physical assets such as a sensor, and actuators actually, and servers, workstation, network devices, and PLCs, and logical assets such as flow graphics, program logics, databases, flow nodes, and firewall rules. These are all what we call as assets, and zones and count units. So the network segregation techniques used to isolate the network and assets to impose and maintain the strong access control on the mechanisms. So we call it as mostly as zones itself. Okay, an industrial network is a network of automated control systems is known as an industrial network, and business network is it's like a compromise of a network. Sorry, yeah, comprise of a network of systems that offers information infrastructure to the business. So like these two networks and like different networks. So if it is a manufacturing business, like let's take car manufacturing, and each and every like the robot which is like implemented over the industries will be comes under a single network. and the other network will be like monitoring the records. So how many workers are coming and going out of it, their attendance data, and how many cars is being manufacturing, and what are the what do you say, the raw materials which we need, how many, like managing the raw materials, etc., etc. This will be coming under the business networks. Okay, and the only the devices which will be coming under the industrial network. And now we are having the industrial protocols, and we have network parameter, electronic security perimeters, and critical infrastructure. So industrial protocols are protocols used for serial communication and communication over standard Ethernets. So we can able to use any kind of Ethernet we want. Actually, it will be mostly actually not the normal Ethernet connection. It will be different. And network perimeter. Not audible. I haven't changed my like mic or anything because we're constantly going in a same patch. So same pitch. And yeah, network perimeter. It is the outermost boundary of a network zone, a closed group of assets. And it is network perimeter is nothing but the network itself, whichever connected in the industrial network. An electronic security perimeter. It is referred to as a boundary between secure and insecure zones. A critical infrastructure is a collection of a physical and a logical systems and assets that the failure or destruction of of which will severely impact the security, safety, and economic or public health. Critical infrastructure is nothing but if we have a failure in the network, we call it as critical infrastructure. And IT or IoT coverage. Convergence. So how it is like mixing it in together. So we have some devices here. Let's take a mechanical device, and that is an OT. And here, if it is connected to any of these, like it can be a cloud server, it can be an internet through a server to a server, and it can be a, like internet network, it can be a storage, data and processing things, or it can be a database, whether to store the data into it. So if these two is converge, it is IIoT. Okay, it is nothing a new concept here. Like an OT is which is connected to an internet or any kind of devices, other devices, like managed devices or storage devices, that we call it as IIoTs, industrial internet of things. So here these things or these devices will be mostly on industrial purposes. Actually, these are all like other devices. So the SCAT, the TCS or PLCs or RTUs, these are all like other like IoTs, or sorry, not IoTs, other like devices, or what we call it as. So here the PLC is nothing but it is the processing unit, the circuit board which is implemented into a robotic arm in an industry, in an like a manufacturing industry. So we have like these kind of different OTs. That's it. These are all like what do we say? We have different terminology or different circuitries which we can able to implement into devices. Okay, so like even it might be like an escalator thing, or escalator in the sense the product has to be going from one place to another. So they might be using a rolling what do you say? I'm forgetting the word here. Track kind of thing. If you haven't seen any like industrial videos in the National Geographic or Discovery channels, so you can be able to see a conveyor belt. Yeah, conveyor belt it is. So those also implemented. The PLCs will be implemented over there. So it will monitor the current speed of it, and also it will monitor how many products or like things such as passing through those belts, etc. Okay. And here we have the PUDU model, or PU or DUE model. Okay, this will like it is not the Bella Padula model or something. Those models is for security purposes, and this is for only for the OT devices. The PUDU model is derived from the PUDU Enterprise Reference Architecture, or PARA model, and which is widely used to describe the internal connections and dependencies of an important components in ICS networks. It consists of 3 zones. Actually, the models is nothing but it is a concept which is already working. So using this, actually, it is kind of an theory kind of thing. So in why we have a theory in the first place, it will simplifies the actual mathematics itself. So it will be using a formula kind of. So let's take a multiplication table as an example itself. So if like 9 into 9 means we have to multiply the 9 by itself like 9 times. Sorry, 9 multiplies by 9, right? So for that we have like a simple table where we can easily match it, right? So for instead of like multiplication table, we have the model here. So how to implement a security on the ODs, like where to implement the IoT device, which mode of transport we have to use, and where we have to put the security mechanisms over there, etc., etc. How to manage things in a security perspective. So they will be deriving these steps and manners in these models. Okay. And yeah, so IoT systems or enterprise ones will have like two levels. One is like level 5 and level 4, and that is for enterprise network and business logistic systems. And in the IDMCs or industrial demilitarized zone, we already talked about DMCs, right? So DMC is normally we'll be using in the cloud infrastructures. So, but if it is comes under industrial, it is called as industrial demilitarized zone, where if the particular devices or the network is compromised, so if the particular OT is compromised, also even though it cannot affect any of these networks. So this is the important network which we have to secure. So it will be in a secured, it will be in a secured location or in a like virtual location, and these will be in the outermost layer. Okay, so these levels is consist of 0 to 3, and in level 3, the operating system or site operations will be there, and in level 2, the control systems or area supervisory control, like managing. Anybody can able to manage the what do we say, the robotic arms nearby. If they want to like shut it down for any like inspect or any malfunctions might be happen. So in order to do that, they have to turn off the machines. So for that, there will be control board over there. So that we call it a supervisory control. Any supervisors in that location or in that area can able to operate that. And in level 1, the basic controls are intelligent devices. So it is like the normal IR blasters, like IR devices, which is placed on over there. It will constantly monitor it is passing through or not. And it is also we can also call it as like motoring devices. It will like it will be like in a circle there will be like some magnets will be placed in a like alternative patterns like north south north south. So by using that, it can able to predict the movement, whether it is in like 180 degree or whether it is in like 110 degree, can able to predict using that motorized function. So that controls will also we will implement it in this level 1, and our actual physical process will be in the lower level. So if any of these like things has been compromised, even though it cannot able to like penetrate into the enterprise network because these two are isolated in this Purdue model. Okay, let's discuss about the attacks which we can expect in the OTs. So lack of visibility, plain text format. Actually, most of the IoT devices, 90% of the devices will be passing the traffic through plain text, and because it is like robot programming, so it is going to be obviously in the plain text because it will be mostly in the like normal code. Okay, and network complexity and legacy technologies and lack of antivirus protection. We can't able to implement a antivirus into an OT. That is not feasible. And lack of skilled security professionals for to manage maintaining those OTs and rapid phase of changes in those devices. And that is also a thing here, or challenges here on outdated systems. And so most people, what they would think is if the location or if the perimeter is secured well enough, there is no need to update the systems in the first place. But the thing is, we are facing the internal threats too in these locations. So that is a no go thing. Without updating the devices, that is a no go thing. And happens on modernizations and the convergence with IT. So when they are converging into IT, like let's say if the organization is going from one to another state, let's take actually in America, like in the Tesla company itself, they are manufacturing the what is the sign? Cars, right? So actually, not recently, it is like it is like already implemented. So he moved into Gigafactory, where he can able to manufacture the recent cyber, right? So for those things, if he doesn't using a cloud thing to store those all these information or data, so he has to implement the data in a cloud because now he has two manufacturing units in a different location. So for those things, for those data, it has to be centralized into the cloud. So yeah, he has to implement this, and it is not very easy to implement this into moving from a local storage into a cloud to for those OTs. It is not very simple. Thanks. And OT devices uses Modbus protocol, as it means if any penetration or intrusion happen, it is always Modbus is to blame for. Uh, no, it can be anywhere. It can be anywhere. That is why we have to monitor those things. That is why we have the tools to manage or analyze those things. It is not only by the Modbus. Each and every OT set is like different, right? So let's take if an OT is using Modbus and another OT is using a Bluetooth base, we can easily like pivot to another OT. So it can be only by Modbus, right? So yeah, let's go further. OT threats, maintenance and administrative threats, and data leakage, and protocol abuse, and potential destruction of ICS resources, and reconnaissance attack and denial of service attacks. Actually, in OT, we are not expecting these kind of threats constantly. It is very in rare case. Actually, it will be mostly in it will be like attacks will be happening in internal threat only. Okay, protocol abuse, we have to like have a very skilled person into the OT environment, but it is not going to happen. But we can able to expect these kind of threats in an OT environment. So HMI-based attacks, exploiting enterprise-specific systems and tools, and spear phishing, malware attacks, exploiting unpatched vulnerabilities, side channel attacks, buffer overflow attacks. Why buffer overflow attack is happening here? Because those devices or those OT devices is using C codes till now. So actually most of the robotic devices is currently using C code now. And some they are using a different actually nowadays they are using a different kind of programming to program those robots and exploiting or remote controls. Yes, I think this is the normal most often threats we will be facing in OTs. HMI based attack. The attacker often tries to compromise the HMI systems as it is the core to the tool that controls the critical infrastructures. And the attacker gain access to the HMI systems to cause physical damage to the SCAD devices or collect sensitive information related to the critical architectures. So the SCADA vulnerabilities exploited by an attacker to perform HMI based attacks or memory corruptions, critical management, code injection, and lack of authorization or authentication to and insecure defaults. Insecure defaults is nothing but insecure default credentials. Okay, let's go further. Now we are into side channel attacks. So the attacker perform a side channel attack by monitoring its physical implementation to obtain critical information from a target system. An attacker uses two techniques, namely timing analysis and power analysis, to perform side channel attack on the target OT systems. So here is the victim here, an attacker computer is here. So once he is using this, it is monitored, so which will measure the oscillation of a signal. So obviously, the zeros and O is nothing but if the switch is on, that is 1. If the switch is on, that is 0. And also using this oscillation scopes, like it is a monitored device, it will be it's like what do you say? The graph will be going up and down, which will like it's just nothing but it is like giving the measurement of the current which is passing through the wire. So using this, using this monitor, he or she can able to easily get the information out of the system. So by analyzing those oscillations, we can able to predict. And if he or she can able to amp those things, we can able to easily get a perfect. Actually, the satellite is also using the radio frequencies. We can also receive the information from the satellites also. Um, like let's say, actually it is illegal to transmit the data all around the world. If you are transmitting the signal to a satellite, that is actually illegal. But the thing is, you can receive the signals. You can use the normal TV dishes also. You need a like RFI connectors into to you like it will like change the modules. It is like an adapter which will change the normal cable like aux cable into Ethernet cable, and from there you can able to easily use any kind of analyzing devices or like scanning devices to capture the signal. Yeah, and then from capture this, you have to like decrypt it signal to get the actual data. For like satellite analysis, we have like, different kind of tools to analyze some things. If we have time, we can have a look into it, but we don't have time here. Side channel attack continues here. So timing analysis and power analysis. So analyzing here the attackers monitors the amount of time the device is taking to finish one process or finish one complete password authentication process to determine the number of correct characters. Okay. And in power analysis, the attacker observes the change in the power consumption of a semiconductor during a clock cycle. By observing the power profile, one of the password can be retrieved, comparing the correct characters with the wrong character. So the thing is, so if you are giving a correct character means, actually the password check is going to be in a character basis. So each and every character will be checked one by one. So if it is a correct characters, the signal would be different and the power consumption would be different. And if it is a wrong character, the power consumption would be different. And the same thing here in the timing. If for a correct character, the timing of the processing will be different. It will be in the nanoseconds. The thing is, using this also, we can easily predict the password of an OT. And hacking the programmable logic controller or PLC, programmable logic controllers are susceptible to cyber attacks as they are used for controlling the physical processes of a critical infrastructure. The attacker identifies the PLC exposed to the internet using an online tool such as Showdown. An attacker can tamper with the integrity and availability of PLC systems by exploiting the pin control operations. Here, it is nothing but we can easily use and publicly available documentations in order to understand the particular and then the particular circuitry, and then from there we can easily implement an attack. But for most of these things, we have to have a hands-on into the OT device in the first place. Okay, from there, once the hackers confirm and with this possible things, we can able to go further. Actually, we can able to create a POC device to have a start the attack to the device in the first place, and hacking industrial systems through RF remote controllers. So we obviously, you guys know what is RF remote, right? So if you are like, let's take the AC remote. Those are all like nowadays it is RFID for the most of the AC controllers. But if you're using like a hybrid ACs, it will be like RF remotes in the most cases. If it is not, it will be like IR blasters. But most cases it will be using RF remotes. And most of the BLDC fans, like the BLDC fans is also currently using RF remotes, etc. The RF remote is nothing but radio frequency remotes. So replay attack is something where the attacker records the command transmitted by an operator and replay them to the target system to gain basic control over the system. So here, the operator is pressing the remote, pressing the button in a remote, and the command is recorded by the attacker's device. And once he captures the data, and she can able to retransmit the attack using the same capture device, and then it will be transferred to the target machine or the vulnerable machine. So let's take in order to disturb the manufacturing unit, so I just need to take taken care of, like what you say. If I like able to control the conveyor belt using an RF relay, we can able to easily disturb the whole unit itself. So unless they are like say secure the traffic, or unless they are like re-implement the device, re-update the rolling codes. Until then, I can able to easily take control over the device itself. Or if it is a robotic arm, it is a different thing itself. This auto like implement a connection or security over it. But these are all things. These things actually for this attack, the attacker has to be in a in a boundary, or in a like a certain what do you say? Attack, command injection is similar to what we have just now seen. The attacker alters the RF packets or inject their own packets employing the reverse engineering technique to gain complete access over the target machine. So using a single code, we can able to identify what are the other commands can be using the what do we say, the documentation over the internet. We can able to reverse engineer the data itself, and then we can able to change it. Actually, it won't be like much of it. So in order to turn on the device, it will be 0 1 0 0 0. So if it is like another turn it off, it will be 0 1 1 0 0 0. So like this, you can easily predict it. Most of the like RF devices, RF control devices, is using the same kind of commands. Okay. Yeah, two RF remote controllers repairing with the malicious RF controls. So attacker hijack the original remote controller and pair it with the machine using a malicious RF controller, and which they disguise as a legitimate one. Pairing using a sequence, an attacker captures the data, and he or she can able to make the this device into like a legitimate device or legitimate RF remote, and then it is like just like kind of spoofing the MAC address. But instead of spoofing, it would be a sequence of packets which will be transferred to the target machine and to the remote. So before any like command will be taken care of, it should be having a like a handshake kind of mechanism will be taken care of. Will be like the package will be transferred to it, and then it will be acknowledged by the target machine, and there will be a session will be started. So just like a pairing a Bluetooth device, that's it. So instead of a Bluetooth device, here it is an RF remote. Okay, let's go further. See, yeah, here we have the attacking tools. What are the tools we can able to use? The ICS exploitation frameworks is an exploitation framework based on the Python, and it is like the Metasploit framework itself. And yeah, we have shutdown tools for the SCADA devices or SCAD OT devices, and we can obviously use the Metasploit itself for these kind of attacks to be taken care of. Actually, that we don't need to like take a whole PC itself. We can able to easily implement in a Pi circuit, and we can easily start the attack over there itself. And not even you don't need to like have like a Kali machine. We just need a Linux based machine to be installed into the Pi device itself. What are the countermeasures we can able to take? So use of the proper build sensor to discover the vulnerabilities in the network and update the systems to the latest technology and regulatory patch systems, and regularly patch systems, not regulatory, and implement secure configurations and secure coding practice for OT applications, and maintain the asset register for tracking and actually I can't able to pronounce this word, and outdated systems. And use a strong password and change the default factory set passwords, and secure remote access through multiple layer of defense by implementing VPNs, and harden the systems by disabling unused service and functionality, and only use the tested and familiar third-party web servers for servicing the ICS web applications, or like managing those OTs portals. And these are all the security tools where we can able to use for the countermeasures of these attacks. The flow mode is and it's an example here, so which empowers the manufacturers and utility companies to ensure the reliability of their industrial network, so avoid downtime and disruption of a service continuity. So it will be implemented in the DMZ or IDMZ, and we can able to monitor like whole entire OT network in the first place. And we have completed our today's session. You guys, we are in Q&A. If you guys having any doubts, please shoot it out now or ask me now.
Recording stopped.
Yeah, I think there is no more questions here. So we close down the session and then we'll see it in the next session, guys. Have a great day.